Previously, we defined immersed submanifolds and embedded submanifolds, and then we said that embedded submanifolds are also regular submanifolds. So let's define and give examples of regular submanifolds. Well, a regular submanifold of a manifold M is a subset that is locally cut out by coordinate functions. So we'll explain in a moment what that means, but let's look at some example in Rn, because this is the thing that we are trying to generalize when we define the concept of regular submanifolds. So the concept of regular submanifolds generalizes the notion of, say, coordinate plane, coordinate line, so on. So linear subvariety of Rn cutting out by coordinate functions. So for example, this coordinate plane, say this x1 equals to 0, this is a regular submanifold. Or this coordinate axis, x2 and x3 equals to 0, this is also a regular submanifold of Rn. Now, so what's a regular submanifold? Well, a regular submanifold of dimension R of M is a subset of M that is locally cut out by coordinate functions. So what we mean is that for every point P in N, there exists a chart of M at P, right, such that N is cut out by N minus R coordinate functions. So for example, in our case, we can rearrange the order of the chart and assume N is cut out by these. So these vanishes on N. For example, let's say M is a two-dimensional manifold, so there is a chart 2R2 at every point. Now N would be a one-dimensional regular submanifold. If at every point P in N, we can find coordinate like this, so that the coordinate, let's say x2, vanishes on N, so N is cut out by x2 equals to 0. Then clearly now N is itself a manifold, so that the term submanifold is apt. So why is N automatically a manifold? Why is it clear from this definition? Well, let's look at this example, for example. In this case, if we restrict this chart to just N, and we get that it restricts, when you restrict it to N, it just becomes this, right? So this is a chart on N, so x1 become a coordinate function on N, and in a general case, when this xr plus 1 xn vanish on this N, then this x1 xr becomes coordinate, gives a coordinate chart on N. Note that we also accept the case when N is defined by the vanishing of none of the coordinate function. So in that case, then N is just a regular submanifold of dimension 0. What we mean is that an open subset of a manifold is a regular submanifold of the same dimension. Note that a regular submanifold has to have the subspace topology. Alright, so what are some other non-trivial examples of regular submanifolds? Well, it turns out that a lot of them comes from solutions of polynomial equations, so actually algebraic varieties. To see why and to understand the more general underlying phenomena, we will discuss the regular level set theorem next.